Look up at the night sky. Each star is a distant sun, its light a messenger from the past. Some of the light you see began its journey before humans even existed. When we gaze at the stars, we're looking back in time. Imagine a photon traveling for 250 million years, since the age of dinosaurs, crossing the universe to reach us. Most photons vanish, but a few complete their odyssey, landing in the mirror of a telescope. Today we'll explore a galaxy called UGC 11397, whose light began its journey when Pangea still existed. That ancient light, now captured by the Hubble Space Telescope, lets us see this galaxy as it was in the dawn of reptiles. We are time travelers, riding on the light from a far-off galaxy. For over 30 years, the Hubble Space Telescope has been our window to the universe. Free from Earth's atmosphere, Hubble captures breathtakingly sharp images revealing cosmic secrets invisible from the ground. Its mission to collect ancient light and turn it into knowledge from the birth of stars to the edge of the universe. Hubble's instruments see through dust, resolve individual stars, and measure the universe's expansion. When Hubble aimed at UGC 11397 in the constellation Lyra, it wasn't just for a pretty picture, it was to study a galaxy's powerful heart. By focusing on this distant galaxy, Hubble reveals the incredible power of a supermassive black hole at work. The resulting image is more than beautiful, it's a window into the forces that shape galaxies. Hubble's image of UGC 11397 is spectacular, a spiral galaxy with swirling arms and a brilliant golden center. Dark dust lanes thread the arms, while blue knots mark stellar nurseries where new stars are born. At its heart blazes an active galactic nucleus, outshining the rest of the galaxy with unimaginable energy. This image connects us to a place 250 million light-years away, showing the galaxy as it was when dinosaurs first appeared. We can trace dust lanes, spot new solar systems, and witness a cosmic city from the deep past. What powers that brilliant core? How do galaxies like this evolve? By studying UGC 11397, we unlock secrets of galactic evolution and our own cosmic origins. This is the start of our investigation, a deep dive into the heart of a distant active galaxy. Let's tour UGC 11397, a classic spiral galaxy, its arms curving gracefully from a bright core. These arms are waves of density, compressing gas and dust to trigger bursts of star formation. We see the galaxy at an angle, revealing both its spiral structure and glowing central bulge. Billions of stars orbit in a cosmic ballet, their paths creating this breathtaking pattern. The spiral arms are creative engines, churning out new stars and planets from cold gas and dust. A well-defined spiral hints at a peaceful history, undisturbed by major collisions. UGC 11397 is a mature, orderly system, a grand design spiral. But beneath its serene exterior lies a heart of unimaginable power. At the galaxy's center, the golden bulge glows with the light of ancient stars, billions packed close together. These old suns are cooler, their combined light creating the luminous core we see. The bulge is a stellar metropolis, a record of the galaxy's earliest days. But at the very center is a blinding point, not a star, but an active galactic nucleus. Here, matter spirals into a supermassive black hole, heating up and releasing ferocious energy. Most galaxies have black holes, but in UGC 11397, the beast is awake and feeding. The golden glow is a beautiful shroud, masking the chaos and violence within. To understand this galaxy, we must peer into the heart of its cosmic engine. Let's gaze at the sprawling spiral arms. Woven into their fabric are dark, intricate filaments, vast clouds of cosmic dust. This dust obscures the stars, creating depth and providing raw material for future stars. Contrasting sharply are brilliant, jewel-like knots of vibrant blue light, the galaxy's stellar nurseries. Here, gas and dust clouds collapse, birthing clusters of massive, young, hot, luminous stars. The interplay between the blue nurseries and the dark dust lanes paints a dynamic picture of galactic life. We are witnessing the cycle of matter in a galaxy. It is a continuous process of cosmic recycling and renewal. These regions of star formation are laboratories for understanding how stars are born. The galaxy is a living entity, and its arms are where we see that life in its most vibrant form. UGC 11397 resides in Lyra, home to Vega, a bright star only 25 light-years away. But UGC 11397 lies far beyond, its light traveling for 250 million years to reach us. This galaxy is a true island universe, a vast collection of stars, gas, and dust. It reminds us the universe is populated by hundreds of billions of other galaxies, each a world of its own. The light began its journey when Earth's landmasses were clumped into Pangaea. It is a message in a bottle, sent across a sea of time and space. The most interesting part of this galaxy's story is hidden from view, concealed behind veils of dust at its very core. At the heart of UGC 11,397 lies a monster, a supermassive black hole. It's an object with a gravitational pull so immense that nothing, not even light, can escape. This black hole is a true giant, possessing a mass estimated to be 174 million times that of our Sun. This cosmic behemoth is the engine of the galaxy. The black hole is responsible for the furious, violent energy erupting from the core. Its immense gravity dictates the orbits of the stars closest to the center. Most large galaxies harbor a supermassive black hole at their core. They seem to be a fundamental component of galaxy formation. The existence of this monster at the heart of UGC 11,397 is what makes the galaxy active. The black hole in UGC 11,397 is awake, and it's hungry, actively feeding. So what is a supermassive black hole? Unlike stellar mass black holes, the origin of supermassive black holes is a big unanswered question. They are millions to billions times more massive than our Sun, Sagittarius. A asterisk in our Milky Way is about 4 million times the mass of the Sun. It creates a deep gravity well that dominates the entire central region of the galaxy. An astronaut could cross the event horizon without being immediately ripped to shreds. Their growth appears linked with the growth of their host galaxies. It's about understanding the life cycle of every galaxy in the universe, including our own. How can a black hole be the source of the brightest phenomena in the universe? The light comes from the material falling towards it, forming a spiraling accretion disk. Friction and intense magnetic fields heat the matter to millions of degrees, creating ferocious light. This process is the most efficient energy conversion mechanism known. A region no larger than our solar system can outshine a galaxy. It radiates energy that shapes the destiny of its entire galactic home. Let's examine the accretion disk, a flattened, rotating disk of plasma. It's a place of unimaginable violence, with magnetic fields creating flares and hotspots. The disk's brightness varies unpredictably. It's a layered system, cooler on the outside, blazing with ultraviolet light in the middle, and reaching millions of degrees just before matter plunges into the event horizon, emitting X-rays and gamma rays. Powerful jets of particles formed by magnetic fields can be launched outwards. The accretion disk is the visible manifestation of the black hole's hunger, allowing us to deduce its nature. By studying the light from the disk, we can measure the black hole's properties and test Einstein's theories. Now we can bring all these pieces together to define our key term, Active Galactic Nucleus, or AGN. An AGN is simply the extremely bright, compact central region of a galaxy whose luminosity is not produced by stars. Instead, it is powered by the accretion of matter onto a central supermassive black hole. The term active refers specifically to the fact that the black hole is currently feeding and therefore producing this tremendous output of energy. The core of UGC 11,397 is a classic example of an AGN. Its brilliance is a direct consequence of its central black hole's voracious appetite. AGN are not all the same. They come in a variety of flavors like quasars, blazars, and Seyfert galaxies. These different classifications often depend on how bright the nucleus is or from what angle we happen to be viewing the central engine. For example, a quasar is an extremely luminous AGN that can completely outshine its host galaxy. A blazar is what we see when we're looking directly down the barrel of those powerful relativistic jets. The underlying engine is thought to be the same in all of them. UGC 11,397 is classified as a Seyfert galaxy. This is a type of AGN typically found in spiral galaxies and is less luminous than a quasar. In a Seyfert galaxy, you can still clearly see the host galaxy's stars. Seyferts are divided into two main types. Type 1. Seyferts have a clear view of the hot, fast-moving gas. Type 2 Seyferts, like UGC 11,397, have their central engine obscured by a thick, dusty torus. This brings us to the next part of our mystery. If the accretion disk is hidden behind a thick veil of dust, how do we know what is happening there? How can we be so sure about the black hole if we cannot see it directly in visible light? The answer lies in looking at the universe with different kinds of eyes by observing high-energy light that can pierce through this dusty shroud. To truly understand this hungry heart, we must venture into the world of X-rays. UGC 11397 is a Seyfert galaxy, named after Carl Seyfert. These active galactic nuclei are a bridge between normal galaxies and quasars. Seyfert galaxies are divided into Type 1 and Type 2. The classification depends on their light spectra. Type 1 Seyferts show broad emission lines, signatures of fast-moving gas. UGC 11397 is a Type 2 Seyfert. It shows narrow emission lines from slower-moving gas. Something is blocking our direct view to the fast-moving gas. The core is obscured in visible light. We must find a way to peek through. What hides the heart of a Type 2 Seyfert galaxy? The unified model of AGN proposes a thick, donut-shaped structure of cold gas and dust, called the Obscuring Torus, surrounds the central supermassive black hole and its accretion disk. The orientation of the torus determines if we see a Type 1 or Type 2 Seyfert. Dust in the torus absorbs energy from the accretion disk and re-radiates it in the infrared, making Seyfert 2 galaxies bright in infrared. If the dusty torus is a thick curtain for visible light, how can we ever confirm what lies behind it? The answer is to look at the universe in a form of light that is far more energetic, a light that can punch right through the obscuring clouds of gas and dust. We must turn to X-rays. X-rays are a high-energy form of electromagnetic radiation, with wavelengths much shorter than visible light. They are produced in the most extreme environments in the universe, in places with temperatures of millions of degrees and intense magnetic fields. The innermost region of an accretion disk, right next to the black hole's event horizon, is one of the most powerful X-ray sources in the cosmos. Unlike visible light photons, which are easily absorbed or scattered by dust particles, high-energy X-ray photons can travel through significant amounts of gas and dust without being stopped. Think of how X-rays are used in medicine to see through soft tissue and image the bones inside your body. Astronomers use the same principle to peer through the dusty torus of a Seyfert 2 galaxy. While the densest parts of the torus can still block some of the lower-energy soft X-rays, the higher-energy hard X-rays can often pass through, giving us a direct if partial view of the central engine that is otherwise completely hidden. This is precisely how the true nature of UGC 11397 was revealed. When X-ray telescopes were pointed at this galaxy, they detected a powerful, point-like source of X-ray emission emanating from its very core. This was the smoking gun. This intense X-ray light could not be produced by stars or any other normal galactic process. It was the unmistakable signature of a superheated accretion disk, the calling card of an actively feeding supermassive black hole. The X-ray observations effectively pierced the dusty veil, confirming the existence of the powerful AGN that visible light observations could only hint at. The study of X-rays from active galaxies has revolutionized our understanding of these objects. By analyzing the X-ray spectrum, astronomers can measure the temperature of the gas in the accretion disk, determine how much matter the black hole is consuming, and even probe the properties of the obscuring torus itself by seeing how it filters the X-ray light. X-ray astronomy provides a crucial, unfiltered window into the chaotic physics occurring just outside the event horizon, allowing us to study these hidden cosmic engines directly, regardless of our viewing angle. The X-ray data from UGC 11397 does more than just confirm the presence of an AGN. It unmasks its true power. The brightness of the X-ray emission allows astronomers to calculate the total energy output of the central engine, known as its bolometric luminosity. This often reveals that the hidden nucleus is far more powerful than it appears in visible light. The energy we see with Hubble is just the tip of the iceberg, the small fraction of light that manages to scatter off surrounding gas clouds and escape in our direction. The X-rays, however, give us a much more direct accounting of the engine's ferocious output. This multi-wavelength approach, combining the visible light from Hubble with the X-ray data from other observatories, gives us a complete picture. Hubble shows us the beautiful structure of the host galaxy, its spiral arms, its star-forming regions, and the golden glow of its stellar bulge. It provides the context. The X-ray telescopes, on the other hand, provide the crucial insight into the hidden core, revealing the physics of the black hole and its accretion disk. It is like combining an aerial photograph of a volcano with a seismic sensor that measures the rumbling magma chamber deep below. Both are needed to understand the whole system. This technique of peering through the dust with X-rays is especially important for finding and studying black hole growth throughout cosmic history. Many of the universe's most active periods of black hole feeding may have happened inside very dusty, gas-rich galaxies, where the activity would be completely hidden from visible light telescopes. X-ray surveys of the sky are therefore one of our best tools for taking a complete census of black hole activity across the eons, allowing us to build a more accurate picture of how these cosmic monsters and their host galaxies have grown and evolved from the early universe to the present day. And so, for UGC 11397, the story of its hidden core is one of revelation through technology. What appears as a serene spiral galaxy to our eyes is unmasked by X-ray vision to be the host of a powerful concealed engine. This discovery highlights a fundamental principle of modern astronomy. To truly understand a cosmic object, one must observe it across the entire electromagnetic spectrum. Each wavelength of light tells a different part of the story. By combining them, we can finally piece together the full narrative of this distant galaxy and its hungry heart. Hubble helps astronomers measure the mass of supermassive black holes. By observing their gravitational influence on stars and gas, Hubble's spectrographs measure the speed of orbiting stars. Above the atmosphere, Hubble sees galactic cores with exquisite sharpness, building a catalog of black hole masses and revealing the connection between a black hole and its galaxy. This suggests a coevolution where galaxies and their black holes grow together. It's a step towards understanding the cosmos. Hubble observes thousands of galaxies at vast distances, acting as a cosmic time machine. By comparing distant young galaxies to mature ones like UGC 11397, astronomers track galactic changes over time. Understanding galaxies like UGC 11397 helps us compare them to the more chaotic galaxies we see in the deep past. Hubble's observations reveal that the early universe was more violent, with abundant quasars and active galactic nuclei. Galaxies are dynamic systems, built through mergers, regulated by black holes, with fluctuating star formation. UGC 11397 is a chapter in the ever-expanding story of the universe. Another fascinating area of research enabled by Hubble is the study of star formation in the extreme environments near active galactic nuclei. The center of a galaxy like UGC 11397 is a chaotic and hostile place. It is bathed in intense high-energy radiation from the Accretion Disc. It is buffeted by powerful winds of hot gas being driven away from the black hole. And it is subject to immense gravitational tidal forces that can rip apart ordinary gas clouds. One might think that such a violent environment would make it impossible for new stars to form. Yet, remarkably, Hubble's observations often reveal that the opposite is true. Hubble's high-resolution images allow astronomers to peer deep into the central regions of active galaxies, sometimes resolving clusters of young blue stars that have formed surprisingly close to the central engine. This presents a fascinating puzzle. How can the delicate process of star formation, which requires a cool, dense cloud of gas to collapse under its own gravity, proceed in the face of such overwhelming disruptive forces? The answer seems to be that the AGN's influence is a double-edged sword. The same powerful outflows and shocks that can disrupt gas clouds can also, under the right conditions, compress them, triggering a burst of star formation. Studying these processes in galaxies like UGC 11397 helps us understand the complex feedback loop between a black hole and its host galaxy. The AGN can trigger star formation, and the newly formed massive stars in turn inject more energy and heavy elements into the surrounding gas through their stellar winds and eventual supernova explosions. This complex interplay shapes the galactic core, determining how much gas is available to form stars versus how much is consumed by the black hole. It is a delicate and self-regulating dance between creation and consumption, between the birth of stars and the feeding of a monster. Hubble's ability to observe in both visible and ultraviolet light is crucial for this work. The ultraviolet observations are particularly sensitive to the youngest, most massive stars, allowing astronomers to pinpoint the exact locations of the most recent star formation events. By mapping out where stars are being born relative to the active nucleus, scientists can test their computer models of AGN feedback and refine their theories about how galaxies build up their central regions. The heart of UGC 11397 is not just a lair for a cosmic dragon, it is also a surprisingly fertile if dangerous stellar nursery. Ultimately, every image from Hubble, every spectrum, and every measurement contributes to building a broader and deeper understanding of the universe. The study of a single object like UGC 11397 is never done in isolation. The data gathered from this one galaxy is added to a vast public archive, a treasure trove of cosmic information accessible to astronomers all over the world. This collaborative approach allows scientists to combine observations, test new hypotheses, and slowly but surely build a more complete and accurate model of the cosmos. Hubble is not just a telescope, it is a knowledge-building machine for all of humanity. The detailed investigation of UGC 11397, for instance, helps us refine the AGN unification model. By combining Hubble's visible light data with X-ray and infrared observations, we can create a complete multi-wavelength picture of its central engine and obscuring torus. This allows us to test the model's predictions and understand the physical properties of the dust and gas that cause the obscuration. Each Type 2 AGN that we can dissect in this way adds another piece to the puzzle, strengthening our confidence that the different types of AGN we see are indeed just a result of our viewing angle, a matter of cosmic perspective. Furthermore, the public release of stunning images like this one has an impact that goes far beyond the scientific community. These images inspire awe and wonder, connecting people from all walks of life to the grand spectacle of the cosmos. They are powerful educational tools that can spark an interest in science, technology, engineering, and mathematics in the next generation of explorers. They remind us of the beauty and complexity of the universe and our own small but precious place within it. Hubble's mission is therefore twofold: to expand the frontiers of human knowledge and to share the wonder of that discovery with the world. And so, Hubble's cosmic mission continues. Even after more than 3 decades of service, it remains one of our most powerful and productive scientific instruments. It continues to measure the expansion of the universe, to map the distribution of dark matter, to characterize the atmospheres of distant exoplanets, and to probe the very heart of active galaxies like UGC 11397. Each new observation builds upon the legacy of the last, constructing an ever more detailed map of the universe and our place within it. The light from this one distant galaxy, captured by Hubble, is a testament to the power of human curiosity and our relentless quest to learn. We began with a single photon, journeying for millions of years from a distant galaxy to the Hubble Space Telescope. We followed that light to the spiral galaxy UGC 11397. In its arms, we see cosmic life and death, and brilliant blue nurseries of newborn stars. At its heart, a supermassive black hole feeds, drawing in a swirling disk of gas and dust. This active galactic nucleus requires multiple forms of light to piece together its full story. The tale of UGC 11397 is a story about the universe in miniature. The study of UGC 11397 is a lesson in the power of perspective. First, there is the perspective of time. The light brings a message from a past so deep it is difficult to comprehend. Then, there is the perspective of technology. Our ability to see this distant galaxy in such detail is a testament to human ingenuity. This elegant theory teaches us that what we see often depends on our point of view. Finally, there is the personal perspective. To look upon an image like this is to gain a new perspective on ourselves. It reminds us of the shared wonder of being alive in this incredible cosmos. Every answer leads to new questions. Each discovery opens a new door. Telescopes are the vessels for our modern age of exploration, charting the unknown. Space exploration is one of the grandest adventures our species has ever undertaken. We are living in a golden age of astronomy. The frontier is endless and our journey is just beginning. The universe is waiting, full of mysteries, and we are and will always be explorers.